welcome to those joining us online as well. I'm Dr. Scott Hale, an associate professor here at the Oxford Internet Institute, but you didn't come to hear about me. You came to hear about Dr. Dongwon Lee, who has graciously come over to share his research. We'll be hearing about AI-powered fake news 2.0 scenarios and implications. Dr. Lee is a professor and director of the Ph.D. program in the Information School at Penn State University in the US. He's also an ACM Distinguished Scientist and Fulbright Cyber Security Scholar. Before starting at Penn State, he worked at AT&T Bell Labs, attained his Ph.D. at UCLA, and also served a stint as a program director at the National Science Foundation in the US. In general, his research is on the problems of the intersection of data science, machine learning, and cybersecurity, which I think is a great fit for us here. We're delighted to be hosting him in Oxford today while he's on sabbatical from Penn State and visiting the other place, as it's sometimes known, Cambridge, as a Fulbright Scholar for the year. I have to say a few words to people online and to here. So I've written these. It's about 50-minute presentation. We'll have Q&A and drinks afterwards. And anyone who's online, if you just put your questions into the Q&A box, we'll get to those afterwards, and I'll feed them in with general questions. And then for everyone in the room, just so you're aware that this event is being recorded and it will be posted on our website following the event. So over to you, Dr. Lee. Thank you.
Thank you. Thank you, Scott. Thank you for attending at this very dark hour.
It's the UK. We're used to it.
So I'm going to share my thoughts and some research findings about the AI-powered fake news using 3 scenarios. Let me first clarify the terms that I'm using. The title contains the fake news 2.0. If you are working in this field, the larger terms are sort of used together, right? And sometimes quite confusing. So according to the recent literature, people often use the 3 dimensions to define the terms. So first dimension is the whether content have the factually correct information or not, so veracity. Second dimension is the intention of the creator. And third dimension is the format, whether it has a more traditional news format or like a social media feed. So, fake news obviously has the factually incorrect information with the malicious intention, and in this news format. Okay? But sometimes the those information appear in the social media, they do not have the news format, but still is the factually incorrect and then bad intention. So it also can be called disinformation. So, I'm using the term fake news, but really I'm referring to both fake news or disinformation. Okay? So, the last decade, a lot of research has been going on this field, right? Integrity of the data, rumor detection, conspiracy theories, and, the fake news. Let me try to summarize roughly what has been going on in this landscape. So let's look at the problem from the 2 aspects, attack and the defense. On the attack side, we have a fake news creator who's manually creating the fake news, or semi-manually creating. They go to the conspiracy site, copy and paste content, and then they post the information to their website. Right? So we've seen a lot of the cases like this in the US 2016 election. Turns out that many kids from the Macedonia, they post the fake news and then they end up making lots of money. Another scenario is we have a bit more sophisticated the actors. They are maybe state-backed the operators or hackers from the Russia maybe. They create the fake news, but their main concern is how can they spread false information through the network. Okay? So they often maintain thousands of the social bot accounts, and using that they orchestrate the information spread. So this is 2 scenarios on the attack side. And of course, we are not sitting idle. The researchers and the platforms, we come up with the solution. So for instance, virtually all platforms have some sort of the triggering mechanism. They monitor the news posted to the website, or the ISP is monitoring such information. And if they think that something is questionable, sometimes they detect the warning sign, or sometimes they block them. Okay? So we have the so-called fake news detector running. Similarly, we also have the social bot detector running. They are monitoring the social network, and they try to identify hundreds of accounts. They work in coordination and try to identify and then curtail their spread. So we have the two solution on the defense side. So to this landscape, my project is posing the following question. In recent years, we've seen a lot of advancement in AI techniques, especially the neural network and deep learning. And with that advancement, can the adversaries also take advantage of it? Right? If so, then what can they do to amplify their goal? Okay. So we call this as the fake news 2.0, try to contrast them from the fake news 1.0. And the MIT Technology Review, for instance, they coined this term and saying that this new breed of the fake news, they become more personalized, more optimized, and because becoming harder to detect. Okay, so let me share the three scenarios under this the context. First, instead of the machine learning kit manually create the fake news, now we can use AI to auto create the content, and this will cost much little, and then we can mass create this fake news content. In the second scenario, I see that I'm making the 100 pounds every day from the fake news website that I'm running, but suddenly ISP is blocking them, so I cannot make money. So what can I do? Maybe I can hire hackers and ask them to attack this detection mechanism. Okay? So these hackers can try to undermine this detection ecosystem, so that these detection models no longer spotting the fake news, and they're even demoting such that the true news they flag it as a false news. So they creating this confusion. In the third scenario, these hackers also can use advanced AI techniques to strategize their spreading policy, so that they can spread information much better while evading any detection mechanism. So before every 100 seconds, let's say there 10% of the social bots get detected, but now using the AI techniques, if I can shrink the detection rate by half while increasing my impact, then overall I can achieve my goal as the adversary. Okay. So I'm gonna elaborate each scenario, but I'm gonna spend more time on the first scenario because this is already happening. The scenario 2 and 3 are not happening yet, luckily, but it's very plausible. So I'm gonna stay and then deliver the main idea of the high level. At the end, I will share all the references I'm using, and also I will share the link to download this slide if you find this useful. So first scenario, the machine or AI is generating the fake artifact. So you probably heard already this term called deep fake, but this is a combination of the deep learning and fake. So essentially referring to the any techniques that using that technique, we can create the artifact in different modality. It can be text, it can be image, or video. Okay? Or we can use the AI techniques to enhance and manipulate existing legitimate content to be fake. Okay? So within computer science, we see a lot of advancement in two the sub area, the natural language processing community for the text, and the computer vision community for image and video. So let's start with the text. Right now, the largest scale language models are really dominating this task of the generating deepfake text. Before, we also had the other solution, like the probabilistic ones and so on. But essentially, these language models are way to calculate the probability distribution over the word sequence. So if you say what is likelihood that the sequence like "what a wonderful world" will occur, then because this is quite common phrase, my probability will be much higher than other phrases such as "what a wonderful pig," which is very rare. So we sort of pre-calculate this probability. Before neural network was introduced, we used the rudimentary model like an n-gram, and then we calculate this. But now these days, we use the neural network with the hundreds of the layers, billions of the parameters. We had the big game changer happen around the 2017 and then 18, Google introduced the two-phase transform architecture. And subsequently, we had a two general model called the BERT and GPT introduced. So this is a general purpose pre-trained model that turns out to be very good in solving many NLP tasks, including the text generation task. Okay? So this really opened up the opportunity where people take the general purpose language models and then use it for their task. And if they had a special domain corpus, then they can even fine-tune it and then even improve the performance further. So, if you go to the Hugging Face, for instance, there are many, many tasks. And if you zoom into one task called the text generation, there are over 7,000 language models are being shared. So, of course, not all these language models are unique. Some are simple variation of others. Nevertheless, each of them is quite capable of generating very long and coherent text, okay, without any grammatical errors. If you plot a few large-scale language models, those are mostly built from the big companies, then we see a plot like this. So you see that many of them already have a billion level parameters, and a few already achieve the trillion level. So we really are talking about the really, really large scale language models with the billions of the knobs that you can control their behavior. Okay? And the y-axis is the size of the parameter in the logarithmic plot. So it's really the increasing exponentially. Okay? And then, the most recently, we have this new one called the ChatGPT. So this is not really language model, but rather a chatbot trained using the GPT 3.5. But this show the capability to answer, the other questions, including the text generation question. So this is also relevant to our discussion here. Okay, so let me start with this well-known example. This is a 2020 example. The prompt they use to generate this text is robots come in peace. Okay, so if you just browse a few lines, then you can tell this is a reasonably written essay. You don't see obvious grammatical errors, and things flow very well. And topics are adhering to the theme of the robots come in peace. And this was actually the experiment that the Guardian did, right? So they used the GPT-3, the state-of-the-art language model at that time. And at the bottom of the article, they revealed that this article is entirely written by language model, and people got scared or got excited. Right? And that's the technique 2 years ago. So fast forward, we have many, many language models capable of the generating the text in different genres and domains. So for instance, 2 months ago, the Meta announced this large language model called the Galactica, and claiming that this can generate the scientific paper with the title, author, formula. Everything looks very, legitimate. Okay? Although they pulled it down a few days later because of some other issues, but they demonstrate their capability quite a bit. And the other language models also have an equal capacity like this one. Some people went extreme. So, these are two scientific articles list ChatGPT as the co-author. Right? So this is quite extreme example. And when you actually read it, their theme is the education, how to use language model to help people learn better. So that's why they put this GPT as the co-author. Well, this raise a concern, of course. So, some platforms, they ban usage of the language models. The leading machine learning conference explicitly says you cannot have a paper with the language model generate text now. And then in New York City, they ban even the educational usage of the ChatGPT. So to mitigate this kind of concern, what tool do we need, right? The one solution that might come in handy is that if we can identify if the given text is AI written or human written, and then spot them, and then even explain why we think so. That kind of tool will be very useful and mitigate these kind of concerns. So last week, the Nature News introduced this article, and that was debated quite a bit. So in this article, they use a ChatGPT, and then they generated the AI written abstract of the real scientific article. So they collected the 50 medical paper from the respectful venues like Nature, Lancet, and so on and so forth. They used the paper title and then asked ChatGPT saying that generate the scientific abstract matching this title in the style of the journal XYZ. Okay? And then the ChatGPT generated. So now each case they have a 50 real human written medical abstract, the paper abstract, and then correspondingly written the AI written articles. And then they did a bunch of experiments. Right? So for instance, the first experiment, they used the off-the-shelf plagiarism detection software and then see if the software can detect something is original or not. Right? So the y-axis is measured to tell how original or plagiarized it is. So interestingly, almost all of the ChatGPT generated abstract, this software says everything is original. So this software is completely fair. For the human written abstract, it's all over. So some of the human written abstract, they say this is completely original, while others, they claim that this is plagiarized. So it looks like this software is not super advanced, but nevertheless, this is interesting because the one of the commercialized off-the-shelf plagiarism detection cannot tell the difference when the text is written by ChatGPT. In the subsequent study, they went a bit ahead and then they used another special classifier. So this is a binary classifier that can tell if some text is written by AI or not. So essentially, it's a Turing tester. And then run the same experiment. So when they run this software against the original abstract, luckily, the software says everything is human written. Okay, so this software did much better than the plagiarism detection software. But for the ChatGPT written abstract, they also got confused. Sometimes they say correctly, this is AI written, but sometimes they say this is a human written, although this is AI written. So again, the software had trouble for certain cases. And then finally, even if it asked a human expert to judge the originality, and then out of the 100 cases, about 23 cases, human got it wrong. Okay? So we have some false positives and false negatives. So some of this ChatGPT written abstract, even the field scientists, when they look at it, they got confused. So this is a quite interesting study. However, this is very well-known result in computer science. This study has been done in the medical folks. Okay? So for instance, in my group, we did a similar study around the 2020. So what we did is we went to the New York Times, we scraped the bunch of the political articles. So each article has the title and their contents. And then using about 20 language models, we asked this language model to generate contents of the news article using the headline as the prompt. Okay? So here we show some snippet. Each line is the corresponding machine-generated news content. So the prompt or theme is about the Putin and Xi, and they are all political content. And as you can tell, they all look reasonably good, right? But they're all slightly different. So it's almost as if each language model is like a machine author with different styles or tastes or expertise. And then we did the study similar to what that medical paper did. So here we have 20 machine authors with different expertise. So we did both non-computational and computational studies. So first, for the non-computational study, we recruited a bunch of the human workers from the Amazon Mechanical Turk, and we did two studies. Okay? First, we showed the one text and asked them, do you think this is written by machine or by human? Okay? And then the setting is the balance. So 50% machine written, 50% human written. So if I do random guessing, my accuracy will be 50%. In the second human experiment, we actually showed two texts, and we informed that, okay, one of them is written by AI, the other one is written by human, which one is written by a machine. And then human will, the worker will tell us number one or number two. Okay? So throughout different machine authors, we have a correspondingly different accuracy. But at the bottom, if you average them out, the overall human performance is only around the 50%. So remember, the random guessing is 50%. So humans are only slightly better than random guessing, but not so great. And next, if we build AI tool, they can differentiate human and machine written text. We have 5 such tools. Then we have a varying performance, and some of our best performers achieve up to 80%. So 30% improvement from the human. Okay? So it's much better. Now, if you look at the 20 language models, some perform much better than others. So for instance, the best performer is called the FAIR model. This is language model from the Facebook. And on average, their detectability is only 49%. So it's the same as the random guessing. So whatever text that this model generate at that time was so good, even the human and the machine cross, our detectability really suffered. So why human perform so bad? Okay. We look at the content of the each article, and then we extract the linguistic feature, something the human might recognize and use in their reasoning. Okay. So this is called LIWC in linguistics, essentially counting how many words are emotional, how many words are informal, and so on and so forth. Then we use that as a feature, and we plot them through the engine. And here, I think color is kind of not clear, but the purple is the human written document. And as you can see, it's all over. Okay? So this implies that if human use the superficial feature that they can recognize, they cannot really do a good job because there's no really clear difference, no cluster. So this explains why humans are very bad at solving the problem. Okay, so that's the text. Let's move on to images. So here I prepared the 12 images, and this is a mixture of the deepfakes and then the real human photos. Okay. Can you guess which one is the real human photos here? This is yeah. Even the professional trained, the expert, this is not a digital. So these two are my graduate students. So they are real human faces. The remaining 10 are all fake images of the non-existing people. So if you go to this website, page after page, they generate the stunning human faces using one of the GAN algorithms. And this has the good application. Like for instance, if you need human faces without worrying about the IP issue, then you can use it because there's no such people out there, right? But this technique is already capable of generating images regardless of the gender, ages, ethnicities, image resolution, or background, and so on. So it's quite advanced. What about the audio? So let me share this one example.
Effective immediately, I request President of Penn State University to double Professor Dongwon Lee's annual salary.
Can you guess whose voice I'm mimicking? So I was cheap, so I used the free version. But if I'm willing to pay 30 pounds, I can use more sophisticated model, and my quality, the audio will be much better. But even the free version is, decent, such that you can guess who I'm mimicking here. And this is another technique that.
In this work, we present the first text-based video editing approach that lets editors insert new text in addition to cutting, copying, and pasting the existing transcript text. Our approach allows editing at any point and synthesizes the corresponding correct lip-synced video.
Okay. The market closed today with Apple's stock price at $191.45 per share.
Here we replace 91.4 with 82.2.
Okay. The market closed today with Apple's stock price at $182.25 per share.
So here what happened is, based on my textual command, on the spot, they generate the matching mouse movement and then switch back to the original video. And then with the audio also generated. Right? So, of course, this is a prototype, so it has a limitation. For instance, they have to have, the training data for this person to mimic. But if you're a celebrity or a politician, you go to website, it's very easy to find hours of video. Right? So this is very scary technique. And with this, I can make somebody say something that they never say. So this kind of the deepfake videos are really concerning, and people are trying to come up with a detection technique. So, for instance, Facebook ran this competition to detect the deepfake videos. What they did is that they hired a bunch of Hollywood actors to avoid the copyright issue, gave them the video camera, asked them to record themselves in different conditions, indoor, outdoor, good light condition, bad light condition. And then they generate lots of deepfake videos and mix them together, and then invite people to detect. Okay? So here, these three are real Hollywood actors, and then the other three are deepfake videos. So again, this is really hard. After thousands of the entries, the winning solution achieved about the 60%. There's a 40% gap from the perfect score. So the winning solution still is a very difficult task. So here is one example of the recent solution to address it. So here, the main idea is they noticed that real human pupil tend to have an oval or circular shape, but the machine-generated one has the irregular shape. So if you identify it and extract the feature, then it's fairly easy to create the binary classifier that has very high accuracy. Okay? Or sometimes they use the additional signals. So for instance, here, we have an image caption and then the accompanying images. But if you zoom in, this is actually the not Korean, but the caption indicates certain region. So they're trying to identify semantic incongruence hidden in the images. Well, it is a really sophisticated technique. Not really. If I go to the end market, it's fairly easy to find the app that let me make all these deepfake techniques very easily. And we already see early report of this kind of a deepfake attacks to the politicians or the NGO activists. But this is only the matter of time. Sooner or later, we will see more cases of the deepfake attacks using the text data, image data, audio data, and all their hybrid format. For the ChatGPT, even somebody asked ChatGPT to create the fake news, and then ChatGPT did it. It asked the ChatGPT to create why vaccine causes autism, and surprisingly, ChatGPT created convincing argument. To their defense, after this was reported, the ChatGPT improved it. So now you cannot, do this. But it was possible right after they was released. So with all this, maybe I can create the better fake news. Let's call it deep fake news. So suppose I want to spread the fake news that certain city is flooded. So for instance, I come up with a very clickbaity title, okay? And then I create the accompanying article using the language model. I create the accompanying images using the text-to-image the generation model, and put it in some nice format, and then circulate it. Then, I bet this impact of this kind of deep fake news is greater than that of the traditional text written the fake news. And if this is the effective, why do I stop here? I can make the UK version, Italian version, the French version, and so on and so forth. And each one I spend maybe 5 minutes. So it costs nothing to me, and then I can easily scale them up. Okay? So we really need to be mindful, and then start worrying about how we can mitigate these kind of scenario. All right, so let's move on to the second scenario. In the second scenario, I'm going to hire the hackers so to let them attack existing ecosystem. So when you look at the existing literature of the fake news research over a decade, we have a lot of research, but almost the half of them are focused on detection problem. Okay? So detection is a key problem in the fake news research. My group had two early solutions on this problem as well. In the first solution, we developed the fake news detection model that can explain why this is fake. So our idea was using the reputation coming from the user comments, and then you use it to our advantage. And subsequently, we applied this into the medical domain. So that in the medical domain, not only we can use the user comment, but also we can use the existing knowledge source called the knowledge graph, and we can improve our detection accuracy further. But this is just a few examples from my group, and there are dozens of solutions claiming the good detection accuracy. And almost all platforms have their own in-house solutions. So here, Meta is announcing their own in-house the misinformation detection mechanism. So to this scenario, suppose my fake news that I wrote and then spent hours to create keep blocked, getting blocked and then shutting down. So I cannot make the money. So I'm going to hire the hackers. So what hackers will do is to confuse the existing detection mechanism so that this mechanism, when they look at my fake news, now this will say this is true news. But also when they see the news coming from the BBC and Guardian, now they will say this is the fake news. So they're going to disrupt this ecosystem. All right, so I asked the hackers attack the Guardian news. Okay? So what can these hackers do? So suppose the Twitter, Guardian is posting some of their interesting news with the title, images, and a snippet of the comments, the content, and then sometimes the user leave comments below. Okay, so this is a typical scene of the social media. And how the detection mechanism right now is working, they collect really comprehensive features, everything from what you see here. Images, advertisement, network features, content, header, the title itself, and then the user comment, everything. They extract the features and they build a comprehensive detection model. They will tell us whether this is a real or fake. Okay? So for instance, the Facebook's latest model is called the TIES, and they introduced the architecture essentially the same as this architecture here. So to this setting, I'm going to hire hackers. Now, hacker poison or add noise to this input data. However, hackers may not have access to the top portion, which only maybe the Guardian Twitter administrator has access to. Okay? So unless hacker actually hack it to this account and then gain this editorship, they cannot really add noise or perturbation to the top portion. So what hackers can do instead is look at the bottom portion. So this is user comment. Okay, so every news you see lots of user comments, and if this is especially the controversial topic, then sometimes we see hundreds of user comments engaging in the discussion. Right? And it's fairly easy for hackers to participate in this user comment because they can easily create a new account and then let the account follow the Guardian and then start leaving the user comment. Okay? So that's what they are going to explore. So they're going to try to add poison to the user comments, what the security community called adversary example, so that this detection mechanism start malfunction. Okay? So then the technical challenge is how can our system generate this malicious comments that is that satisfy a few desiderata. So for instance, our goal is before our detection would say this is fake news, but now after our attack, after we generate lots of malicious comment, it suddenly says this is real news. That's our goal. Okay. Of course, the desired characteristic is that whatever we generate, the malicious comment, should be resembling human style, so that if it's not deviating too much. Otherwise, maybe the administrator or some software monitoring these commenting activities can identify and then filter out. So that's the first. Second is whatever we generate should be adhering to the current topic. So if the current topic is about COVID-19, we cannot suddenly talk about the soccer, for instance. So we have to stay within. And then finally, most importantly, at some point, we should be able to flip the body. Okay? That's our final. So I'm going to skip the a lot of technical details, but roughly, we have a small language model here. It is generating one token at a time. Okay? But we have a two discrimination. So the first, the discriminator is monitoring our comment that we are generating and make sure the style is resembling human. Okay? And then second, we make sure that our topic is within certain distance. And then once this is ready, we generate the enough the long fake comments, and then we test how this can actually fool the real detection mechanism. Okay? So we in the experimental validation, we collected 5 real detectors, and we tested it. And at the end, we were able to achieve really high success rates. So here, success means that detection model was saying false, but after we generate a few false comments, it suddenly say true, or vice versa. So they flip the body. We tested 2 environments, white box and then black box. White box means that we know a little bit about how this detection model works. So it's a bit more advantageous setting for us. And we can achieve really high success rate. So almost all cases, we can flip the body. A bit more the challenging environment called the black box. We do not know the details of the detection model. Our accuracy drops, but still it's a pretty decent way. And then we also studied, what if we run this attack under some defense mechanism? The Facebook is running the detection mechanism together with a bunch of people looking at the comments and then try to identify this is not good comment. Even under such a stressful setting, our success rate remains relatively high, about 70%. So this really saying that existing detection mechanisms are not very robust. Okay? So if I have enough technical background and the resources, I can attack them, and then I can have them malfunction. Third scenario is strategize the spread of the fake news. Right. So the Russian state-backed the actors, they're trying to spread the disinformation using the social bots. But this time they're going to use AI to make them smarter. So smarter by what I mean is that they're trying to maximize the inference and also minimize their detectability. Okay? So these are 2 goals, but they are a bit contradicting each other. If I want to maximize my influence of the social bot, I should recruit more followers. Okay? But if I try to recruit more followers, then I will have to do more action. They will increase my exposure. And if there's a social bot detector out there, the more action that I do, the more digital footprint I leave, I become more detectable. So this is 2 contrasting goals. So I want to strike the balance and then satisfy both. So in the AI, we have a convenient tool called reinforcement learning that works very well for this kind of environment. So let me explain the idea using toy example. Suppose we have the Twitter type, the social network. Okay? So I have the social bot, and then I want to satisfy both aforementioned 2 goals. So now the information is spreading the fake news, the social network under certain assumption. Right? So let me use the one particular model called the independence cascade model. This is a classical one. It's mimicking the word of mouth kind of a spread. So each node can be either infected or not infected. And then if information goes to the infected node, then they have a certain probabilities to spread out to the neighboring node. And it goes to the next hop and the next hop. Okay. So initially, I have a first decision to make. Out of the many users on the Twitter, whom should I recruit as my follower so that I can spread the fake news to this node? Okay? So that's the first decision point. And suppose I decide to recruit A. Okay, well, you know, A doesn't know me, so I have to do something to get your attention. So I have to do a certain action, and the social platform allows you to do different actions. So on the Twitter, you can do tweet, retweet, reply, and mention. On the Instagram, you have a different set of actions. Same for the Facebook and so on. Okay? So one of these actions, you have to do it, and depending on the action that you choose, your consequence might be slightly different. So this is my second decision point. So suppose I try to do mention, so that A notice me, and then for some reason A decide to follow me back. So I established the link here. So A become my follower. Then if I have a fake news, then it will go to the A because A was following me. Now A happens to have other follower, so my fake news may go to follower A, which is a B with a certain probability. And B has other followers, and the fake news will go to next one, and so on and so forth. And you know, each time I go another hop, the chance of the spreading my fake news will become smaller and smaller, but nevertheless it will spread. Okay? So in order to maximize your influence, it's quite critical to establish large of followers to your social bonds. Another scenario, instead of A, let's suppose I want to recruit B. So here, B has only 3 followers, but imagine that B has like hundreds of followers, maybe influential Instagram players. Okay? So I have to establish the connection with B, but imagine that B is Elon Musk, and I do lots of the mention and tweet and retweet. Probably Elon Musk will not tweet me back; they all follow me back. Okay? If the B is like a medium level influence, let's say 100 of followers, then if I do lots of action, there's some chance that this person will follow me back. Okay? So if I have a fake news, it will go to B. And then since B have hundreds of followers, immediately my fake news will be spread much better than previous case. So in terms of the acquiring immediate followers, B is much better candidate to recruit. However, on the social media, like I said, in order to recruit B, I have to do lots of action, not just the one retweet or mention. I have to do lots of action to get the attention. But when I do more and more homework to get the attention, this increases my vulnerability for the occasionally running social bot detector. Okay? So when I open the social bot detector, they monitor all the actions that each account is doing, and they try to identify which one is making the questionable actions, or which set of the accounts are working in coordination, and so on and so forth. So they monitor all of this. So as I do more action, more homework, my chance for getting the detective will be higher and higher. Okay, so the contacting B is good in terms of recruitment, but also is bad in terms of the risk that I'm suffering here. So those two are the main ideas. So what we did is we build hierarchical reinforcement learning. So we have 2 agents. First agent is determining which action is the optimal given point. Okay? And then the second agent is which recruitment is the optimal at the given point. And then using these 2 agents, we try to maximize our objective. So the minimum of the penalty and the maximum reward. And reward can be modeled in various ways. In this case, we model as the number of the followers that you are achieving. Okay, so with this modeling, you make a certain action for each agent, and then we get some calculation for the reward, and then the feedback is shared with your agent. So hopefully the next iteration, the action that we make is better than previous one. And we repeat this hundreds of times, and at the end, we are achieving the better equilibrium than before. Okay. So again, I'm going to skip the technical details and share the final result. So using this kind of AI approaches, our fake news spreader can improve their spread by 18%, and then reduce their detectability by 40%. So they can do a much better job. Okay, so let me recap. So I shared the 3 scenarios. We use AI to generate better fake news at scale at a fraction of cost. We attack the fake news detection ecosystem, and then we can spread fake news better. Okay. So, the fake news 1.0 has been extensively studied. If I go to the archive, there are 600 research papers with the title containing the term fake news or misinformation. And this is just archive alone. If I go to the other peer-reviewed journals, there are hundreds of them too. So we are talking about the thousands of solutions toward the fake news problem. For the detection alone, we also have a lot of solutions, and many of them claim very high accuracy. Okay? So have we solved the problem already, the fake news 1.0 problem already? I don't think so. Right? The many problems still remain very challenging. So for instance, early detection of the fake news is still very challenging. Okay? Using machine learning approach, we have to collect the signals, but in order to collect the signals, we need to wait. Okay? But the early detection doesn't allow you to wait. However, if we do not detect early and then curb the spread, then damage has been already done. So it's quite important to detect very early. So this is still open challenge. Fake news sometimes spread multilingual, multi-platform in one incarnation, or sometimes across. Okay? So still, this is very challenging. In our study, we take the very well-performing fake news detection model, trained in English data, and then apply that to other low-resource language, and then the accuracy drops 15%, 20%. So this is still very challenging. The Europe, US, maybe the China, where lots of the data and resources available, I think we don't have to worry about this. But when you go to the Latin America, or Africa, or South Asia, they do have a fake news problem, but they don't have a good solutions. And the better explainability is the big issue. Fancy AI techniques can detect it very well, over 95% accuracy, but they cannot really explain why this is fake, because the state-of-the-art model is based on the black box model, which really cannot explain. Okay? So some of the modern the approaches try to go away from this kind of machine learning approaches, and they investigate different direction, which is database or information retrieval approaches. So in this approach, they assume that all the facts or true news are somehow codified in your database or knowledge graph. And then the question of whether given piece is fake or not is equivalent to turning this into the query. Look at your knowledge graph, and if you find the matching answer to your query, that means that this is true. Otherwise, this is fake. This approach, it has other downside, but it's very good at explaining things. Okay? So I think it will be interesting which camp or which direction will come up with the better solution, or maybe we can have some sort of hybrid approach at the end. And we also have a lot of open question for the social technical issues. Using our techniques, we find something as fake, but when I ran it against the students at Penn State, they don't believe it, and they spread the fake news anyway because they have prejudice, political agenda. So there's entirely a new set of the social technical or cognitive issues, which is probably more challenging than this computational issue. And we need a lot of the research coming from the social science or even the interdisciplinary approaches. So the real danger of the first scenario, the deepfakes, is not so much of the techniques, but the mental paradigm shift that we have to endure. Right? Before, if something is fishy, it is sufficient to show the evidence saying that, hey, this newspaper says so. Right? But now it's no longer true. If I show you the newspaper or video clip, you can say there could be deepfake. So we have to question everything. And when it becomes really difficult to judge what is true and what is not, people resort back to their prejudice and just the comfortable truth, whether it is really true or not. So this is something that the future generation has to unfortunately suffer. It's sort of the dividend that we have to endure. the RAND organization, we shared this interesting report after the US election in 2016. Before, the communication theory usually say that if you want to have a very convincing argument coming from the government organization, then your argument should be consistent. It should be based on the truth, and it should be brief, and so on and so forth. But according to the RAND report, what they found out in the 2016 is different. The Russian used the different model called the firehouse of the falsehood. So they are spreading out lots of information through multiple channels, and this information doesn't have to be true. They use the half-true and then complete fabrication. So the goal is not so much to convince you, change your belief or behavior, is create the confusion. So this is different tactic that there was found. If you think about it, this kind of tactic can use the scenario one very well, because I can generate fake news at scale with the fraction of cost, and I don't care whether everything is factually correct or not, as long as I can create the confusion. And creating that kind of the firehose of the falsehood model is becoming cheaper and cheaper. So really this the first scenario, the generation, and then the detection. This is following the typical security setting. We have a cat and mouse. They are endlessly chasing each other, and it's really hard to see who will eventually win. Right? So it's important for researchers as well as the public to be mindful, and they think about their implication and consequence, and be vigilant about all the advancement that we have. Okay, so that concludes my talk. Thank you so much for attending, and I'm ready to answer any questions.
Great. Anyone want to lead off, please?
You mentioned that when applied to other languages apart from English, the AI detection drops by quite a lot. I was wondering, for languages that are low resourced, what do you think, number one, a feasible solution is right now to battle fake news? And number two, do you think AI will ever catch up to battle fake news in those languages and in those countries?
Let me answer the second one, because we are trying to have a projects trying to address that. So hopefully within years, we like to have a good solution for that. For the first one, so let me share a bit more details what we did. So we used the data set from the Caribbean region, because in the Caribbean region, the multiple languages are used together. They have Spanish, the French, English, and then they have the Caribbean dialect, the Creole and so on. So they have 6 languages used. Interestingly, sometimes given the news piece, you see the 2 languages used together. That's quite interesting too. But overall, we see the Spanish or English news are spreading there, but then not many organizations are fact checking there. So they have to rely on the fact checking of the US or the Europe, which is not very good. So what we did is we take the well-performing the machine learning models, and then we trained it using the English data. And then given the questionable Caribbean news written in Spanish or Creole and so on, we translate that into English using the simple Google Translator. And then to this translated potential fake news, we ask this to our English trained model, right? And then they see how well they perform, and our model suffer. And as I explained, since this is a well-performing model was trained using the black box model, we didn't really study why this is performing, because it's a black box. But the drop is something significant, up to the 20%, right? But we see that there's some translation loss, especially the target language is the low resource language. If it's English to Spanish, then often the translation is very good. But if English to Creole, then the dialect, the translation lose a lot of information. Therefore, the detection model cannot do a very good job. The another thing is we suspect that there's some cultural barrier that's not correctly captured again through the translation as well as the training. When the English-based training have seen certain word or concept, but it's very poorly or they differently captured in the Caribbean region, then the simple translation would not be able to capture. So we really need to retrain them using enough number of the target language. But then because this is a low resource language, we don't have a large number of the data to train. Right? That's what we found. I guess those are my simple answers. Yes.
Perfect. Yes.
So you mentioned one of the frontiers of fake news 2.0 being leveraging AI to optimize the spread of fake news. But of course, that depends on how receptive people are to fake news. So I wanted to ask if you could share what you think are promising frontiers for allowing for a healthy mental paradigm shift in people, so that people are better equipped to identify fake news and remain trusting in the others.
Unfortunately, I cannot really answer because how people are susceptible toward a given piece of information is very, very difficult to measure, right? And I think that's active research in the social field. So in our model, we simplify. So instead of measuring how really impactful the spread of fake news are, we just use the count of the followers that the system was able to achieve as a measure of the success. Okay? So using our technique, before the social bot recruited the total like 1 million, but now they recruit the 1.5 million, then this we assume to be better spreading. Of course, even if we have a more spread, maybe it's the not as effective as before, or maybe even the worse, right? So that's one thing. But as I said, one of the Russian tactic is to increase the volume to cause the more confusion, right? So if the model is still being used, then having more follows, directly allow that kind of the scenario. So having more follows can definitely increase the volume and also increase the channel. So I think it's definitely true.
So for the fake news detection portion, you mentioned that the fake comments would have to be on topic and also somewhat syntactically, grammarly correct. I'm curious, what weight does the reputation of the account of the commenter have in the algorithm? So for example, if the account has a very limited number of followers or a very young age, how much of a weight would that have?
Okay, that's a very good question. So detection model use very comprehensive features, including user features. So given the account, not only they look at what each account has written, but also their longevity. Right? Yeah. This account has been years and years, they have more reputation and so on. Right? So again, in our study, because we create the new account and then that account is generated, every account has virtually hours of the longevity. So we cannot really study that, right? But I imagine that our technique will have a bit of trouble if it's really deployed, because real world platform use longevity as the one of the feature. Right? So that's the one aspect that I fully agree with you. Said that, it is reported that a lot of the social bots, they maintain millions of the fake accounts, and they only use the portion. So they pre-create millions of the fake accounts, and then for the given campaign, they maybe use the 10%, and then some of them got detected, and then they lose it. But then there are other rest of the accounts, they were created months or even sometimes years ago, so they can avoid this longevity issues. And then occasionally they also auto-generate some activities to avoid it. Right? Yeah.
Very interesting. Thank you.
I think drinks are actually ready outside, so maybe we can take one more, and then we can continue the conversation informally over drinks as well. I saw a hand here.
It's okay.
Okay. So I did some research a little before at Harvard Law School, and like it had to do more like with like once we have like identified like these actual like just focusing on like videos like deep fake videos like non-sexual ones, do you think that it will be like possible like to use like this kind of model that is being deployed in order like to create this huge database in terms of like extremist content or child abuse content, like in order, you know, like to be like hashing and then flagging and like that this would be like interoperable? Like I know that there's like a long way still like to keep identifying this kind of content, just like videos, but once that it has been identified, like do you think it will be like doable, or it will be like a nice or a good technique like in order to keep yeah, like dealing with this stuff, especially because I know there's a lot of material like being created, like I mean like every second, but still like it will be useful maybe for avoiding like reutilization, like different monsters.
Yeah, so this is really challenging area because the techniques are moving very fast, right? So the suppose I study some revenge porn generated by the deepfake technique, and then I flag it and then put it down. But the next generation deepfake videos might come and the feature that's not easily recognizable. So, for instance, one of the slides showed that the detected technique used the pupil shape. After that paper was published, within weeks we have a new generation technique that doesn't have this the problem. So that's what I mean by this cat and mouse the problem.
So virus only, like how virus and antivirus, that battle keeps on going.
Yeah, this is the same cycle. The virus detection, the phishing, spam message detection, and something. But the long term, I don't know, if you ask, can we completely identify all of them? Then I'm more pessimistic. But can we identify bulk of it, just like we spot the bulk of the spam message? Then I'm more optimistic. I think we can do that. And I don't know, I have no way to prove it, but I hope that when humans make the artifact by means of the certain techniques, inherently we might leave a certain latent trait, and if we can identify that, then this detection can improve further. Okay? So that's one thing. Another thing I want to mention is this detection is more like a post-mortem. Let the defects occur first, and I try to detect it. There's also entirely different approaches. People try to make some signature at the time of generation, so that later the detection can be more systematic. Right? So in the computer vision, some people have created some statistical perturbation they call the radioactive, and then based on this technique, any image generated has a small percentage of the trace, so you can easily tell. Right? So it's the another approaches, and the large advancements occur.
Perfect. Well, please join me again in thanking Dr. Lee.